It has been known for decades that estrogens are protective in many neurological disease models, but mechanisms have remained unclear. The estrogen type, dose, and timing of treatment are all important factors. Estrogens can act on two types of estrogen receptors, ER-alpha or ER-beta. Since ER-alpha mediates the adverse effects of estrogens, focus has been on development of selective estrogen receptor modifiers that act only on ER-beta. These are termed ERβ-ligands. Multiple sclerosis is an autoimmune disease characterized by loss of myelin and axons in the central nervous system. Years ago, our group was the first to show that an ERβ-ligand was protective in the animal model of MS, experimental autoimmune encephalomyelitis, or EAE for short. Treatment with the ERβ-ligand improved clinical outcomes, increased myelin, and increased the number of axons in spinal cord. In the paper published in Brain, we now show that ERβ-ligand treatment involves a novel neuroprotective mechanism in EAE. First, we created a conditional knockout mouse where ER-beta was deleted only in myeloid immune cells that are resident to the CNS or migrate there during disease, namely CD11c positive cells. We found that removing ER-beta from CD11c positive cells blocked the beneficial effect of the ERβ-ligand treatment on EAE clinical outcomes, myelin, and axons, and also prevented the immunomodulatory effects of ERβ-ligand treatment on CD11c cells within the CNS. Bone marrow chimeras were then used to show that ERβ-ligand acts directly on myeloid-derived macrophages and dendritic cells, not on microglia, to modulate the inflammatory microenvironment within the CNS during EAE. ERβ-ligand treatment also increased the number of mature oligodendrocytes, cells that make myelin. This was potentially important since in MS and EAE, it is thought that there is a failure of oligodendrocytes to mature and make myelin. These data show that immunomodulation of the CNS microenvironment can permit the maturation of oligodendrocytes during disease. This would be an indirect effect of ERβ-ligand treatment on oligodendrocytes and remyelination. To address whether there was an additional direct effect of ERβ-ligand treatment on oligodendrocytes, we next created a conditional knockout mouse where ER-beta was deleted only in oligodendrocytes using the OLIG1 promoter. We found that removing ER-beta from OLIG1 cells prevented the beneficial effect of ERβ-ligand treatment on clinical outcomes, myelin, and axons, while immunomodulation was unaffected. This meant that there were also direct effects of ERβ-ligand treatment on oligodendrocytes during disease. Thus, when either cell type, myeloid cells or oligodendrocytes, was targeted for ERβ-ligand deletion, neuroprotective effects of treatment were lost. Actions of ERβ-ligand treatment on each cell type were necessary but not sufficient. This shows how direct effects of a treatment on two distinct cell lineages can have complementary neuroprotective effects. It also emphasizes the importance of developing treatment strategies for MS that not only induce remyelination, but also inhibit the pro-inflammatory microenvironment within the CNS. Summary. In the multiple sclerosis model, EAE, myeloid dendritic cells, macrophages, and lymphocytes enter the CNS, while microglia and astrocytes become activated, together creating a pro-inflammatory microenvironment. This pro-inflammatory environment causes demyelination and axonal loss, while inhibiting oligodendrocyte maturation and myelination. Estrogen receptor beta ligand treatment acts directly on two distinct cell lineages, CD11c positive myeloid cells and OLIG1 positive oligodendroglia. ERβ-ligand actions on CD11c positive dendritic cells and macrophages modulate the pro-inflammatory microenvironment to reduce demyelination and spare axons while facilitating oligodendrocyte maturation indirectly. ERβ-ligand actions on OLIG1 positive cells increase oligodendrocyte maturation directly. Thus, complementary actions on two distinct cell lineages underlie ERβ-ligand's neuroprotective effects during EAE.